Hello there, Algebras. Welcome to your Chapter 10, Lesson 2, Day 2 notes on solving quadratic equations by completing the square. Now, we are going to follow these steps that I have laid out right here at the beginning. These are the same steps that we talked about yesterday. Yesterday, we said, well, okay, let's just get into actually applying these steps and seeing what types of answers that we are coming up with, depending on what's on that other side of the equal sign when we're creating our perfect square trinomial. Okay, so let's actually get into some review from yesterday. So let's solve number 1, x squared minus 10x plus 1 equals 0 by the method of completing the square. And notice the directions in this section say we want simplest radical form as our final answer. So that's kind of giving us a clue we're probably not going to get an integer answer. Well, the first thing we need to do is subtract this 1 over to the other side of the equal sign. So you're going to see me not showing quite as many of my steps, even though I will say things like, oh, I'm subtracting 1 from both sides of the equal sign. Notice what I did was just move that negative 1 to the other side because 0 minus 1 is negative 1. As I was rewriting my pieces of my polynomial I needed, I also put a plus blank on both sides of the equal sign, knowing that, okay, I'm going to create a perfect square trinomial. I'm going to need to make my own C term to do that. So how do I find my C term making this a perfect square trinomial? I look to my B term. I say, okay, I've got negative 10. I divide my B term by 2, then square it. So negative 10 divided by 2 is negative 5. Negative 5 squared is 25 on the lines provided. Okay, so those go right up on those blanks. Now, you went out of your way to make this a perfect square trinomial on purpose so that it would factor to become one binomial squared. How do I find that binomial squared? I personally look to the middle and I say, oh, I got a negative 10 right here. Negative 10 divided by 2 is a negative 5 in the binomial. And remember, it's whatever that variable may be. We have had nothing but x's in our notes, but I know sometimes on the homework there's another variable besides an x being used there. Well, meanwhile, while we were dealing with a perfect square trinomial and creating our binomial squared that we were looking to make, on the other side, on the right-hand side of the equal sign, there's just integers that add and subtract. So negative 1 plus 25 is a 24. Now, we went out of our way to make a binomial squared so that we could take the square roots of both sides. So the root, the square root, and the square cancel each other out, and just the stuff inside the binomial, the x minus 5, comes down to the next line. I bring down my equal sign, and I always need to put a plus and minus in front of whatever it is that's going on that other side. Now, this is where our chapter 9 work comes in handy. Is 24 a perfect square? No. Is 24 evenly divisible by a perfect square? Yes. Okay, so radical 24 separates into radical 4 and radical 6, 4 being the perfect square. I take the square root of 4 and get 2. So plus and minus 2 radical 6, both the positive 2 radical 6 and the negative 2 radical 6 come down to this next line. And now to finish this by getting x alone, I add 5 to both sides. And when I add this rational number to both sides of the equal sign, it always goes in front of the plus and minus. No matter what is behind the plus and minus, your rational number that you're using and moving over here has to go in front of that plus and minus. Okay? I get 2 answers here. I'm going to tell you that it's 2 irrational roots, and they are 5 plus 2 radical 6 and 5 minus 2 radical 6. And we can represent both of them by continuing to have this plus and minus in between the 5 and the 2 radical 6 that we have there. So now this was a situation where, we ended up with 2 irrational roots. It's pretty common when it comes to solving quadratic equations by completing the square that our 2 answers would be irrational, because this method works for rational or irrational roots, either direction. okay? I want you to pause this here, and I want you to try number 2. Again, completing this in simplest radical form. So our final answer in simplest radical form. So since we did this yesterday as well, you should be able to handle this. Pause it here, solve for number 2, and I'll see you in a moment with the answers.
12 seconds later.
Okay, we get x equals -6 plus and minus 3 radical 3. That is 2 irrational roots again, because what really determines it is this number on the other side of the equal sign that I need to take the square root of, is it a perfect square or not? And since 27 is not a perfect square, I am going to get 2 irrational roots. It doesn't matter if it can simplify or not. That part isn't important. If there is a radical remaining, you have 2 irrational roots as your answers. Okay? Okay. So now what we're going to do today is we're going to look at, well, what if we aren't asked to have our answers in simplest radical form? What if we are asked to represent our answers in decimal form? So notice this section of directions asked me to round to the nearest tenth. That's one place behind the decimal. So, okay, the whole process of solving is still the same. It's just at the end, we're actually going to plug into our graphing calculator, and we're going to see what we get for the radical as a decimal. So actually, if we have a radical present, we don't need to simplify it in these cases. So I'll show you what I mean. I'll do number 3, and I'll let you try this with number 4. Maybe I won't. Maybe I'll do number 4. A negative in front of the x squared, I'll handle that. Okay. X squared plus 2x minus 6 equals 0. Well, if I'm creating a perfect square trinomial, then this 6 needs to go to the other side of the equal sign. So this part of the process, exactly the same as before. You make sure any C terms are on the other side of the equal sign added to your 0, and then you, on the next line, include your plus blank to put your perfect square C term on there. So what's going to make a perfect square trinomial here? Well, -2 divided by 2 is -1, and -1 squared is 1 on each of these lines. So I made a perfect square trinomial on purpose so that I could make it as a binomial squared. -2 divided by 2 is -1, so x minus 1 in parentheses squared, there's my binomial squared. Meanwhile, on the other side of the equal sign, 6 plus 1 is 7. So when I go to take the square root of both sides this time, and my square and square root cancel each other out, I bring down x minus 1, I bring down my equal sign, I bring down my plus and minus. 7 is not a perfect square. 7 is not evenly divisible by a perfect square, so it's a plus and minus radical 7 that comes down to this line. Last step is usually add this 1 to both sides, and it goes in front of the plus and minus. And this is where we normally stop and say, oh, we've got 2 irrational roots. Well, this time, the answer is still that there are 2 irrational roots. But we are going to find each of these separate roots to the nearest tenth in our graphing calculator. So I'm going to type in 1 plus radical 7 and see what I get and round it to the nearest tenth. So I get this decimal 3.6457, blah, 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 blah. Rounding to the nearest tenth means looking at the hundredths place, this 4, and asking yourself, well, 4 and down, we would round down. So we keep that as the 3.6. And then 5 and up, we round that place up. So in this case, it's going to be 3.6. Okay. Now, let's also try 1 minus radical 7. So 1 minus radical 7 gives me, this time it's -1.6. So x equals -1.6. So notice we had to round, we were rounding. This didn't end up with terminating decimals, but this is still 2 irrational answers that I rounded to have rational equivalence on my paper. So because this was still 2 irrational roots, even though I rounded for these answers, that's 2 irrational roots. So like I said before, I'm still going to do number 4 because there is a negative in front of my x squared, and I don't love you handling that on your own. So we cannot have any number in front of our x squared except a positive 1 in order to complete the square. So if I end up having a negative in front of my x squared, all I do is just divide everything by -1, including the 0, the other side of the equal sign to start out, because that will change this x squared to being a positive x squared. Now it does change all the other signs as well. It becomes a -12x. It becomes a +3. 0 never had a sign, so its sign doesn't change, but everything just swaps signs. And now I can move that 3 to the other side of the equal sign and leave a plus blank. And since I moved it by subtracting, it's a -3 plus blank over on the right. Filling in the blank, -12 divided by 2 is -6. -6 squared is 36. So that goes on both blanks. I create my binomial squared, which -12 divided by 2 is -6. So x minus 6 in parentheses squared is what I get for my binomial squared. Meanwhile, 36 minus 3 is 33 over on this side. And then I can just go and take the square root of both sides. I get x minus 6 equals plus and minus. Okay. 33 is not a perfect square. 33 is not evenly divisible by a perfect square, so guess what? It's plus and minus radical 33. Normally, my last step would be adding this 6 to the other side, and it goes in front of whatever the plus and minus holds. Now, this just tells me that my answers are 2 irrational roots, and we know that because we're stuck with the radical forever and ever. The 6 cannot combine with that at all because they are separate sets of numbers, types of numbers, so they're not like terms. Okay. But this time, I actually have to find the to the nearest 10th equivalent. So 6 plus radical 33 is the first thing I plug in, which I get x equals 11 point, keep that 7, 11.7. And on the other side, it's going to be 6 minus radical 33. Oh, I get, it's still positive, just barely. I get 0.3. We have to round that 2 up because the number next to it was a 5 in the decimal. So this is still 2 irrational roots because if we didn't round, we would have had non-terminating, non-repeating decimals. Okay, and we know that because we're stuck with the radical 33 forever and ever and ever. Okay, so let's look at the other side. A couple more examples. All right, I would like you to pause here and try number 5 and number 6, keeping in mind that this section asks me to find simplest radical form. And then I'll come back and do one more to the nearest 10th, and then have you try one more that's to the nearest 10th. Okay, so let's pause it here and have you try 5 and 6.
Seconds later.
All right, how did we do? So in number 5, so what's making the difference here? Because actually, I had the same number filling in the blank for both of these questions, didn't I? I had 16 filling in the blanks on both sides for both of these polynomials. But here's the deal. When your number on the right is a perfect square, you take its square root, now you've got rational numbers. They actually add and subtract. So you are not done until you've actually added, combined the two like terms that can combine. 4 plus 5 is 9. 4 minus 5 is -1. 2 rational roots. You're done when you add the 4 over and in front of the plus and minus here because you cannot take the square root of 21. I would if I could, but I can't. So because I can't, and because radical 21 is irrational, that 4 cannot actually add and subtract with the radical 21. And though that is giving me 2 irrational roots over here. Now, they do have decimal equivalents. Okay, you've got, hold on, where's my cursor? There we go. 4 plus radical 21. Okay, so about 8.6. And if I press second and enter, it tells me the last thing, it retypes for me the last thing I typed in. So I can arrow to the left and change that plus to a minus. And now I've got the 4 minus radical 21 I want. And that gives me that this equivalent would be negative 0.6. So we do still have, notice non-repeating, non-terminating decimals, we do still have 2 irrational roots that if in decimal form, we could round and get rational equivalents. But radical 21 is irrational, non-perfect square under the radical. Let's do one more together and then have you practice on your own. Sorry, someone left something on my desk that got smudgy. All right, I'll do 7, you'll try 8. These are answers to the nearest 10th. So this is telling me that radicals aren't where I stop. I actually have to plug into my graphing calculator. I start by adding 9 to both sides. I get x squared minus 4x plus blank equals 9 plus blank. Fill in the blank. 4 divided by 2 is 2, and 2 squared is 4. A little bit odd, but it's the case. We factor x squared minus 4x plus 4, which is a perfect square trinomial, back into the 2 binomials that it came from, that it foiled from. We're unfoiling it back. And when we do that, we're going to get the same binomial, so we can write it as 1 binomial squared. That was the whole idea of this whole thing. Take negative 4, divide it by 2, you get negative 2 right here. Meanwhile, the regular old integers that are on the right-hand side, 9 plus 4 is 13. So now the whole idea was to get this binomial squared so that I could take the square root of it and get x minus 2 out. Meanwhile, I bring down my equal sign and my plus and minus, and I ask myself, is 13 a perfect square? Nope. Is 13 evenly divisible by a perfect square? Nope. Well, I guess it doesn't matter because my answer is going to be to the nearest 10th. So I bring down my plus and minus radical 13, add the 2, and it goes in front of the plus and minus. So that rational number goes in front of the plus and minus. And now, because I need to round to the nearest 10th, where this is where I would normally stop and say, here's my 2 irrational answers. Well, now I'm going to go to my graphing calculator and I'm going to plug in 2 plus radical 13. And I'm going to round to the nearest 10th. So I'm going to get 5.6 as my first answer. And then I'll press second and enter, and I'll just arrow left to change this to a minus sign. And then I'm going to get x equals negative 1.6 as my other answer. Okay. Please try number 8. Let's see how that goes for you. We'll come back and just wrap things up. All right, so pause this here and try number 8.
12 seconds later.
All right, so how many of you tried to take the square root of negative 10 on your graphing calculator and got an error? Right? Because we can't take the square root of a negative number and get out a rational answer, right? Or excuse me, a real answer. It's not rational, it's not irrational, it's not even real. If you run into a negative under the radical, that's where you stop immediately and you say, oh, I don't have a real answer here. No real answer, 0 real roots. And this is what we are going to talk about in lesson 4 of this chapter, is the fact that you can have 0 real roots, 1 real root, or 2 real roots as potential answers for solving quadratic equations. And so this was just a little taste of, oh boy, that's a problem to have a negative under a radical. We'll talk more about that in lesson 4. All right, sorry to spring that on you. I hope that you didn't panic completely, but that is where we get into all this types of roots that I've been talking about as I am teaching this. Okay, the types of answers that we can get, how many, the number of things we get as answers, as roots, and what type they are. Okay, my fine friends, please practice in 10-2, homework number 2. Let me know if you have any questions, and I will see you next for my favorite formula in the world, the quadratic formula. See you later.